All right, so our number is 0.000055. Now remember, this is a small decimal. So for small decimals, the leading zeros are not significant. So all that zeros right there, none of that's significant. And the only significant figures are going to be these. Therefore, we can say that we have two Sigfigs. Therefore, our scientific notation should have 2 digits. Now, once again, we want the decimal point to be between the first two significant numbers. So therefore, let's place a yellow marker where we want the decimal point to be, and now we count the moves. So here we go. 1, 2, 3, 4, 5, 6. So to express this in scientific notation, we would say 5.5 times 10 raised to something. Now we have to ask ourselves, is this positive scientific notation or negative scientific? So, since we had a small decimal, we would use negative. If it was a big number, we would use positive. So we would say, since we have 6 moves, we put a 6 there, and we say -6. It is okay to say 5.5 capital E -6. Either one of these is okay. Now let's try another example. In this number, we have a fairly big number, 18.002. So let's talk now about big numbers with decimals. So in this case, you would ignore any leading zeros, but keep any trailing zeros. So if we have 18.002, we would say, well, we don't have any leading zeros. These zeros that are in the middle are sandwiched, and we're going to keep those too. So therefore, all of these numbers are significant. So therefore, we can say we have 5 Sigfigs. Now, once again, to change to scientific, we want to move the decimal point to between the first two non-zero numbers, and so we want the decimal point to be in that position. So let's count the number of moves it would take. You just have to move it here, and you'd have 1.8002 times 10 raised to something. We have to ask ourselves, how many moves was it? And is it positive or negative? Keeping in mind that positive is big and negative is small. So, keeping in mind that it took one move and that we started with a big number, we put the 1 because of one move, and because it was a big number and not a small decimal, we would say +1. So you could write as your answer 1.8002 uppercase E1, or just times 10 to the 1 would also be fine. All right. So I want to do one more example. So here's an example that has the same number 3 times in a row, but written differently. 800, 800.0, and 8.00 times 10 to the second. All 3 of these numbers are the same, but they have different numbers of significant figures. And I'm going to throw this question to the audience at this point, and let's start with 800. So remember which zeros don't count when you have a big number without a decimal point. And see if you can figure out how many sigfigs are in that first number. These zeros are not significant, and only the 8 is significant. Therefore, we have 1 sig fig. Now, when we put the 0.0 in there, that changes everything. That's a big number with a decimal. So in that case, trailing zeros do count as significant. So let's try this one. How many significant figures would the second version have? This is actually 4 sig figs, because the 0.0 does count. Anytime you have a big number with a decimal point, all of the trailing zeros count, even the one after the decimal point. All right, so next one. This one's already in scientific notation, and it says 8.00 times 10 to the second. How many sig figs are in this one? This is 3 sig figs, because in scientific notation, all the numbers are significant. So because you have 3 numbers, you have 3 sig figs. So you can see that you can write exactly the same thing 3 different ways and have different numbers of sig figs.